People are wonderful and are extremely hospitable.
Assalamu alaikum.
Assalamu alaikum.
What is your name?
My name is Carlos Herdeiro. I'm from Portugal, from Waheed University, that's in the center of Portugal, and I'm a research full professor there.
Okay, what is your, you can say, study area?
So I work essentially on black holes and compact objects, more from a theoretical point of view, but also connecting to observations and experiment, mostly gravitational waves and lensing properties of black holes, like black hole shadows. That's my main interest.
What do you mean a black hole?
So a black hole is a region of space-time where the gravitational force is so large that even light cannot escape from it. We call it a trapped region because everything is trapped in there. And we know that black holes exist in the universe. They are actually quite abundant. They result from the death of massive stars. So they are like the final stage of the life of some stars, sufficiently heavy. And this is one type of black holes. And another type is that at the center of most galaxies, including our own, there is what we call a supermassive black hole. That is a black hole that has a mass not of a few stars, but the mass of millions to billions solar masses. That is the mass of a million or a billion suns. So these are gigantic black holes, and that exist at the center of almost every galaxy.
Okay, how many black holes exist in the space?
We do not know the exact number, but they are probably as abundant as stars, say. And you look at the night sky and you see many stars. You do not see the black holes because obviously they do not emit any light, but they are there. And because they do not emit any light, it's challenging to actually find them. How do we find something that does not emit any light? Well, you find it by looking at the effect that it has on the neighboring bodies. So if there is a neighboring star, it will orbit the black hole. We can trace, say, the orbit of this star and realize that there is something there that is giving rise to this particular orbit. And this is a way in which many black holes were identified in the early days. Nowadays, we have other ways to identify black holes because we've detected something called gravitational waves. So maybe you want me to say something about gravitational waves?
Okay, what is your opinion or motivation for the students who like to, you can say, come into the research after their BS, even that into the BS?
Well, I think that the most fundamental motivation is to understand the physical universe. We are moved by the sense of the mysterious, and the world is beautiful and it's mysterious. Then if you like also physics and mathematics, this area of black holes and more generally relativistic astrophysics, it brings together some of the most beautiful physics and mathematics together with observations of some of the most fascinating objects in the universe. So it's really an active area of research. In the last few decades, it has really improved because now we have observations, which before we did not. We have images of black holes, and we have some kind of sound of black holes, which are these gravitational waves. And therefore, it's a kind of a golden era to come and help us to unveil and unravel this mysterious part of the universe.
Okay, you have conducted or attended so many, you can say, the conferences in different countries. So what is your observation? Or which thing is unique which you have observed by coming Pakistan?
The hospitality. People are wonderful and are extremely hospitable, and they've been giving us the best possible hospitality that I've experienced in any. I've been to hundreds of conferences and I've never witnessed such welcoming and warm hospitality.
Thank you very much.
Thank you.